Greetings friends, welcome to our channel CodeChef. If you want to learn competitive programming or you want to master data structures and algorithms, then this is the right place for you to be at. Every week we upload CodeChef contest video tutorials and videos on various important data structures and algorithms. If you are new to the channel, subscribe to the channel and turn on the notifications. In the previous videos, we learned what are greedy algorithms, how are exchange argument used to prove whether greedy algorithm is correct or not, and various tips and tricks so that we can disprove our greedy algorithm easily. Today we are going to solve a problem, and while solving this problem, we are going to use all the concepts that we have learned previously. So let's dive into the problem. This problem is a CodeChef problem with problem code as LEMUSIC, and the problem name is Little Elephant and Music. I'll summarize the problem for you. So there are n songs in total. Each song is represented by its band number and the length of the song. Now we need to find some ordering of playing all these songs. What will the sweetness of one song be? It will be equal to the product of the length of that song and the number of different bands that were played before this song. Now what we need to do is we need to find the maximum possible sweetness if we play all of these n songs. In this problem we need to maximize the total sweetness. So this is a maximization problem. Now let us try to think of a greedy approach to solve this problem. So what does this problem state? So there are a few songs. Each song is represented by its band number and its length. Now we need to play these songs in some order such that the total sweetness is maximized. What will be the sweetness? It will be the length of this song multiplied by the total number of distinct bands that are played before this. And also note that we need to include the current band also. So we need to find the total number of bands that have been played before this particular song. Let me call it as CI. So what we need to do is for every song, we need to find the summation of its length into the number of different bands that have been played. And after deciding the order of playing all of these songs, we need to find the summation of this Li into Ci. And what we need to do is we need to maximize this value. Let us think of some greedy approach first. So one greedy approach that comes into my mind is, since the contribution of each song, that is the sweetness of each song, is dependent on number of distinct songs that have been played before it, and also since the length of each song is going to get multiplied by number of distinct songs before it, so it's always favorable for me to have as many different songs that are played before a very large music song. That is, if there is a song that has a length of 10 and if there is a song that has a length of 5, then it's always favorable for me to play the song with length 10 after the song with length 5, because if I play this song later, then the contribution will be 10 times number of songs that are played before it. If the song with length 10 is played later, then there are greater number of distinct bands that can be played. So from this I can easily say that it will be always favorable for me to have a song with a lesser length before the song with a greater length. So this will be my greedy strategy, that I am going to arrange all of these songs on the basis of the length. The song with lesser length will be played before and the song with greater length will be played after. And after that I will find the total sweetness of all the songs. And then I will report my answer. So this will be my greedy strategy. There is no guarantee that my greedy strategy is actually correct. So let us follow all the tips and tricks that were discussed in the previous video. First, try as many small cases as possible. So we have a few sample cases in the given problem. Let us try on them. Our strategy sorts all the given songs based on the length. So since all the songs have the same length, so we can play this video first. So we can play this song first, then this song, and then this song. What will be the total contribution? Since when this song is played, this is the only band that has been played. So 2 times 1 plus when this song will be played, there will be 2 different bands. So 2 times 2. Then when this song will be played, there will be three different bands. So 2 times 3. In total, this will be 2 plus 4 plus 6, which is 12. And we can see that 12 is correct. Next, we'll try for this case. Here we'll play based on the sorted value of their length, which means this will be played first, then this, and then this. So when this song is played, we'll get 2 times 1 because this is the only song that is played. Then when this song is being played, we'll get 3 times 2. After which when this song is played, we'll get 4 times 2. So what will our total sweetness be? It will be 2 plus 6 plus 8, which is 16. And we can see that 16 is the correct answer. So based on the two sample cases, we feel that our solution might be correct. But now let us try some more example so that we can be pretty sure about our solution. For this example, if we sort them on the basis of the length, then this will be played first, then this, and then this. So let us find what's the total sweetness. It will be 2 times 1 because only one distinct band has to be played. Then it will be 3 times again 1 because note that both of these band number is same. So there is only one distinct band that has been played. Plus now 4 times 2. So in total the contribution is 2 plus 3 plus 8, which is 13. So we believe that 13 is the optimum solution. But now let us try another solution for the same arrangement. Let us try to play 1, 2 first, that is this song first. But then let us try to play 2, 4 and then let us try to play 1, 3. Let us just check what the solution for this particular order be. We'll still have 2 times 1 because only one video has been played. But now when this particular video is played, there are two distinct bands. So we'll have 4 times 2. After which when this particular video will be played, there are still two different bands that have been played. So this will be 3 times 2. Note that now I have not arranged based on the increasing order of the length. But what is the total sweetness value? It's 2 plus 8 plus 6, which is 16. Note that in this approach you have got a better value when compared to our greedy solution. So this says that our greedy solution was actually incorrect. Now we have found one test case where our greedy solution fails. Now let us try to analyze which part exactly did our greedy solution fail at. One thing that we can note is that our greedy solution does not make sure that all the different songs are played earlier, because as we can see from this example, if different songs are played earlier, then in the future songs will have a greater contribution because there will be greater number of different songs. So our greedy solution does not take care of this fact that playing different bands before will be helpful for us. So now let us incorporate this thing into a greedy solution and we'll make our greedy approach as the following. So first what we'll do is we are going to play all the different bands, and after playing all the different bands only we are going to play some band again. Is that is if there are three songs of, let us consider band B1, then one of band B2 and then one of band B1, then always first we will play B1 and B2. After that only we will repeat another band for B1. So this is our greedy strategy 1. But along with that, please note that the concept of sorting that we used, that is playing a song with lesser length before playing the song with greater length, will also be useful, because if we are playing a song with a greater length later, then there is a greater contribution for that particular length. So we have two greedy strategies now. First, we'll play the songs with different band earlier, and then when comparing two songs, we'll play the song which has greater length afterwards. So this is our greedy strategy. Now let us try to test whether this greedy strategy works on the given samples. When we consider the first sample, since all the bands are different, and since in our solution also we have considered all the different bands before, so our solution here is same as our new greedy solution. So this thing will be correct. Similarly here, we have played the song with band 1 first and then the song with band 2. That is, we have played songs with different band before. So here also a greedy strategy is still followed. But now let us try to solve this particular test case with our new greedy strategy. Before playing two songs of the same kind, we are going to play one song of the different kind. That is, firstly, when compared to these two songs, I am going to prefer the song with lesser length. So first 1, 2. After which I am going to play the song of some different band. So it will be 2, 4. When all the bands have occurred at least once, I am going to play the songs of same band. So now 1, 3. So now let us find what's the contribution. That is, what's the total sweetness. We can see that it will be 2 times 1 because one band has been played. Then here 4 times 2 because two different bands have already been played. And then it will be 3 times 2. In other words, our total contribution is going to be 8 plus 6 plus 2, which will be 16. And this is the maximum value that we can get. So now our new greedy strategy looks better. As you can see that first we have come up with one strategy, but then when we made multiple test cases and by analyzing few edge cases, we were able to find that our greedy solution was actually incorrect. And then we slowly transformed our greedy solution to the right greedy solution. So this is a problem solving technique that can be developed with the help of practice. Now we have tried using multiple small test cases. What was step 2? Our step 2 was, once we have tried multiple small test cases, let us try to prove our solution by the method of exchange argument. So let us do that. Consider that we have two solutions. One is the so-called optimal solution and one is our greedy solution. In the so-called optimal solution, we are not making sure that bands of different kind are played earlier. As we can see that here, before B3 is played, itself B1 is played. But here we are in our greedy solution, we are making sure that B1, B2 and B3, three different bands are playing before there is a repetition of band. Now let us try to see what happens when we exchange this optimal solution with our greedy solution. What is the score obtained? That is, what is the total sweetness obtained in the optimal solution? It will be L1 because that's the only band that is played, plus 2 times L2 because there are two bands that have been played, plus again 2 times L3 because there are only two different bands, plus 3 times L4. So this is the value that we get from our optimal solution. Now let us see what do we get from our greedy solution. It will still be L1 because only one band is played, plus again 2 times L2. But this time we can see that here there are three different bands that have been played. So here this will be 3 times L4. But when we consider this L3, we can see that there are three different bands that have been played before. So this will be 3 times L3. As we can see that our greedy solution gave us a better answer. It didn't give us a worse answer, but rather it gave a better answer than the so-called optimal solution. This means that our greedy solution is actually the optimal solution. Next, we will prove that if there are two videos, one with length L1 and one with length L2, such that L1 is lesser than or equal to L2, then it's favorable for us to play the song with lesser length before the song with greater length. So what is our greedy strategy? According to our greedy strategy, L1 will be played before L2. But now let us consider that there is some optimal strategy which plays L2 before L1. Now in that case, what will our score for optimal strategy be? Consider that there are X different bands that have been played before this. Consider that there are X different bands that have been played before this. And consider that there are Y new different bands that are playing between these two songs. Similarly is the case here. So now in the optimal strategy, we have our contribution as X times L2 plus X plus Y times L1. Now let us see what does our greedy strategy give. Our greedy strategy will give X times L1 plus X plus Y times L2 because L2 is played later. Note that this is equal to X times L1 plus L2 plus Y times L1, while this is equal to X times L1 plus L2 plus y times L2. One thing that we should note is that since L2 is greater than L1, since L2 is greater than L1, our new solution, that is our greedy solution, is for sure not worse than the optimal solution, because we can see that these two values are same, and y times L2 will be greater than y times L1 because L2 is greater than L1. In other words, by making this exchange, we made sure that the greedy solution that we have made has at least as good as solution as the optimal solution. In other words, we have proved that in spite of making this greedy exchange, we are going to maintain the optimal property. That is, this greedy solution is our optimal solution. So by considering both the cases, by considering both the properties of our greedy solution, we can make sure that our solution, our greedy solution, is now actually correct. Since we have formally proved our solution, so we can be sure that our solution is actually correct. Having reached the optimal solution, now let us try to code the solution. But before coding the solution, let us summarize all the points that we have collected. First greedy strategy that we saw was all the songs that have different bands will be played before any band will be repeated. That is, if we have any band that gets repeated, then it's for sure that all the different bands will be played before the repetition of any band. So that is our greedy strategy 1. And what is our greedy strategy 2? When comparing any two songs with length L1 and L2 such that L2 is greater than L1, it will be favorable for us to play L2 after L1 if the first greedy strategy is not broken. So with these two things in our mind, we'll have a look at the code of the solution. So first we are taking the total number of test cases, after which for each test case we are first taking the number of different songs, after which for each song we are taking the band number and length. Note that in order to implement this solution, I have used a map such that in this map what I have done is for each band I have stored all the different songs that are being played. That is, for each band I am storing the length of each song that is being played. So how am I doing that? For in the map, for this particular band, I am pushing the length L. That is, L is the length of the song that is being played. So after doing that, after all the inputs are being read, what I have is for each band, I have all the different songs that have been played for this particular band. So what are the total number of distinct bands that I have? That thing can be easily found by the size of the map that I have. So different bands equals to m dot size. After that, what I am planning to do is I need to take one occurrence from each of the band. So what I am doing is I am iterating through the entire map, and then for each key what I am doing is I am creating this vector which is length. What is length? It is the length of all the different songs that belong to this particular band. Okay. Now after getting this particular vector, what I'm doing is I'm sorting this vector because I've already stated that when compared to two different songs which have length L1 and L2, the song which has the greater length should be played later. So after I sort all the length, what I'm going to do is I'm going to use the song with the smallest length earliest. So this will be the song that will be played when we are considering all the songs of different bands. So I'm pushing this particular song in this vector which is smallest, and all the other songs of this particular band will have the contribution as different bands. Why is this the case? Because since I've already played all the different bands before, so now when I consider a repetition of this band, it is for sure that all the different bands have already been played. If all the different bands have already been played, then the contribution of this particular length is going to be number of different bands into this length. So I am simply adding that contribution into my answer. Now in the smallest vector, what do I have? In this vector I have all the smallest length songs that belong to each of the bands. That is, in this vector smallest, for each of the given band, I'll have the smallest length song. And then what I'm doing is I'm sorting all of these songs based on the length. Why am I sorting? Because of the same reason that when comparing two different videos with L1 and L2 length, I should always consider the video with greater length afterwards. So when I have sorted them, then what I can do is I can iterate through the entire array which is the smallest. And then for each song, what I can do is I can find the total number of bands that have been created before this, and it will be equal to different bands. And I can multiply it with the length of this song. So after all this iteration is over, in this variable answer, I have the contribution of all the songs. So at last I can print the answer. So now let us try to submit our code and be sure that our solution is actually correct. So we'll submit the code here. Now we need to wait for the result. We can see that our solution has got accepted. Now let us try to summarize all the things that we have learned in this video series. Firstly, we have understood what are greedy algorithms and how are greedy algorithms used in order to solve optimization kind of problems. Then we realized the importance of proving whether our greedy algorithm is right or wrong. And then we also realized that sometimes it's necessary for us to make multiple smaller test cases so that we can disprove and at least be sure that our greedy solution is right or wrong. So these were all the basic tips and tricks that were required in order to solve greedy algorithm problems. So in the next part of this video series, what we are going to do is we are going to solve and understand the greedy algorithm for many classical greedy problems. Understanding the solution for these classical greedy problems will help us to solve many variations of these problems, and hence they will improve our speed and accuracy on these kind of problems. Until then, goodbye and happy coding.